Now we'll see the characteristics of center of mass. Okay, so to find any center of mass for any particle or any object or any thing, then we need of some characteristics to find that center of mass. Okay, what are that? There are few characteristics are there. First one, center of mass of a total system. In this total system, center of mass does depends only on the particles which are present. Okay, it depends only on the mass of the particles and their relative positions. Okay, center of mass depends on the mass of the particle and relative positions of the particles. Okay, and next point, sum of all the moments to be, here will be the center for this particle, here center of mass is there. Okay, so here where the mass is supposed to be concentrated or may not be concentrated also. Okay, so sum of all the moments of mass of the system of the particles at this center will be 0. Center of mass is 0. That means summation I equal to 1 to n mi xi will be equal to 0. Okay, if you add all those things, then that will be 0. Okay, so mi xi already you know, so m1 x1 plus m2 x2 plus m3 x3 plus m4 x4, like that. If you add all the things, the total will becomes 0 at the center. Okay, next point, the mass of the particle need not be present, no need to be present at the center. Here no need to be mass at this. For example, if we consider a ring, for the ring also center of mass will be here, but there is no mass at all, it's just empty space only. Okay, so that is mass is not to be presented, it's not mandatory not to be present at center. Okay, that is the third point. And next, location of mass is independent of the reference frame. Whatever the reference frame you can take, from that it is an independent. So independent of reference frame, however you want you can take it, independent of reference frame. Okay, so center of mass is independent of reference frame. And main important point is, if no external force, if there is no external force acts on the system, then the center of the mass may be at rest. If there is no external force, if the external force is 0, then object may be at rest or moving with uniform velocity. Very very important point. Okay, clear? If there is no external force, the particle may be at rest or it is moving with uniform velocity. When it is moving with uniform velocity, it has only translatory motion. Okay, it has only translatory motion and it does not exhibits rotatory motion, it will go straight only. Okay, now clear? Right, next point. So here, position of center of mass, this position of center of mass does not change due to internal forces. For example, let's consider it is a bomb, one bomb. So this is the center of mass, it is going to be blasted here, two pieces. Then the center of mass will be here, the center of mass does not change, center of mass remains same, its path, in its path center of mass remains same, it's not going to be changed. Okay, center of mass does not changes by the internal forces. Okay, if internal forces does not affect or does not affect or does not affect the center of mass. Okay, these are the characteristics of center of mass. Okay, now what are the methods to locate the center of mass? Methods to locate center of mass. So generally here there are three ways are there. First one, method of method of symmetry, and second one method of decomposition, and third one method of integration. Okay, there are three methods are there regarding this. Okay, to locate the center of mass we can use these three methods. So I'll just give overall, then after we will discuss individual. Symmetry means exact position. For example, this is a one sphere where the center of mass will be at center. If this is the rod, where the center of mass will be at the center. Okay, got the point? If it is a ring, where the center of mass will be, here it will be. If it is a triangle, then here it will be at the centroid. Okay, then decomposition means, for these are all are regular bodies. If it's an irregular body, if like this body is there, then, or like consider like this one body is there, then how can we mark the center of mass? By using the decomposition method we are about to find out. That means we are going to separate the particles, separate the masses. We are going to make as pieces. From that we are finding the center of mass. And third one, integration. This integration will be done for continuous mass distribution things, objects. Okay, continuous mass distribution objects, we are about to find this integration. Okay, right, we'll see now. So first one, method of symmetry. Method of symmetry. So what is the method of symmetry? For example, let's take one circle. So where the center of mass will be here. So where you have drawn the points, all the points were supposed to meet, that is the one. So it might be for sphere as well as it might be for disc also. Okay, if you take on triangular lamina, triangle. Symmetry means for these two it lies exist in between. Okay, for these two it lies exist in between. Okay, in this, for these two it lies in between, for these two it lies in between, where all three are supposed to meet at this point. So this here is the center of mass will be there. So this point is called as center of mass, and this point centroid. At the centroid only center of mass will be concentrated. Okay, we'll see now. There are two masses. Let's consider one mass m1 and small mass em2, two masses. So let's consider this distance is r1 radius and this radius is r2. Okay, it's an r1 and it is r2, two radiuses. Now we can find, we have to take one reference point. Let me take this as our reference point. Okay, anywhere, if wherever you want you can find reference point. Here is also, here also, here also, here also, here also, wherever you want you can find out. You can take from this point r1. From this point, it is, this point is at a distance of r1, this point is at a distance of r1 plus r1 plus r2. Okay, got it. Now I am going to take from this point, as this I point considered as 0, origin point. Okay, so now m1 m2, m1 m2. So x1, m1 is at a distance of 0, as this point now we are considered. Next x2, x2 now this one, where it is placed, it is at a distance from this r1 plus r2. Next is at a distance of r1 plus r2. Okay, so these two are I consider as a disk. Okay, disk has area, it has area. Okay, right. So from this, what is the x center of mass? m1 x1 plus m2 x2 by m1 plus m2. This is the basic we know. Okay, so now if actually here both the masses are different, if masses are same, if masses are same, then m of x1 plus x2 by 2m, gets cancel, x1 plus x2 by 2. What is the x1 here? 0. x2 is r1 plus r2 by 2 when masses are same. Okay, but the condition is masses are not same, no. So from this, x center of mass equal to m1 x1 is 0, so this total term will be 0 plus m2 x2 is r1 plus r2 by m1 plus m2. Okay, did you got the point? So r1 plus r2. Now x center of mass is 0 m2 into r1 plus r2. So here I want to find this. This is the area. Generally, what is the formula? Density equal to mass by volume. Here it has area. So mass equal to density into area. Okay. So mass equal to density into area. What is the formula for area here? It is pi r square into t, thickness of the disc. So it is pi r2 square, r2 only, no, m2 means here it is r2, right? m2, then it is an r2 by r2 d by r2 square dt by m1 plus m2 of r1 plus r2 by same pi r1 square dt plus pi r2 square dt. So pi gets cancelled, dt gets cancelled, and remaining r2 square of r1 plus r2 by r1 square plus r2 square. Okay, this is for disc. If there is spheres, spheres spheres means what will be the volume? Sorry, what is spheres means? It has volume, not an area. So that means density equal to mass by volume. So mass equal to density into 4 by 3 pi r cube. So if it is a mass m1 and its radius r1, is the mass m2, radius r2, then m1 equal to 4 by 3 pi r1 cube d, then m2, then 4 by 3 pi r2 cube d. Okay, so now also I am considering this is an horizon. Your wish, if you want to consider here, wherever it is, you need to understand the concept. Okay, so from this point it is at 0 comma 0, and m1 is at a distance of 0, m2 is at a distance of same r1 plus r2. Okay, so x center of mass is m1 x1 plus m2 x2 by m1 plus m2. So x center of mass equal to m1, this total term will be 0, m2 is nothing but 4 by 3 pi r2 cube d, into x2. X2 is r1 plus r2 by m1 plus n2. m1 is 4 by 3 pi r1 cube d plus 4 by 3 pi r2 cube d. Here 4 by 3 pi d, 4 by 3 pi d common, so 4 by 3 pi d gets cancelled. So then x center of mass equal to r2 cube of r1 plus r2 by r1 cube plus r2 cube. This is for sphere. Okay, before one we discussed for disc. Okay, right. Now we'll see for rod of length L and another rod of length L. Both are placed perpendicular to each other. Both lengths is L only. Okay, and both masses also let it take equal. Okay, both the masses and both the lengths are same, two identical, or if you want you can consider different also. Okay, let it me take, okay, let's take equal. Fine. So now for this, where the center of mass will be? Center of mass will be lies at this point for this rod. For this rod, it will be lies at this point. So I have to consider one origin point. From where can I consider as origin point? Let me consider one origin point from here. From here, let me consider. Okay. So this is an origin point. This is M1. This is M2. Lengths are equal. Masses also might be considered as equal or may not be. Not an issue, whatever it is. Okay. So let's consider this distance as x1 and this total distance as x2. As I consider this is m1, so x1, this is x2 as that is m2. Okay. So same x center of mass equal to m1 x1 plus m2 x2 by m1 plus m2. So x center of mass m1 is just m1, x1 is x1 at a distance of, this total length is L. What will be this length? It will be L by 2. So L by 2 plus m2, x2 is at a distance of L by m1 plus m2. Now I want to find here m1. m1, this is the m1. m1 means this is the rod only, no? Rod means it have only linear it was. Okay, linear density. So density equal to mass by length, as it is a linear density. Okay, so mass equal to density into length. So that length is L. m1 is dl, m2 is also dl only, as the length have taken same. Okay, so m1 is dl, so L by 2 plus dl into L by dl plus dl. So x center of mass is, dl will be taken common. We'll take dl common. So L by 2 plus L. L by 2 plus L by 2 dl. dl gets cancelled. Then x center of mass equal to L by 2 plus L by 2. That means L plus L. Okay. L plus L by 2 plus L by 2. So that means LCM is 4. 2L will be here, 2L plus L. So it is 3L by 4. So what is the x center of mass? 3L by 4. Okay, got it? Right. Next, if, so this is the method of symmetry. Fine. Next, method of decomposition. Method of decomposition. Okay, so now what I told about decomposition, if you have taken any one object which is irregular in shape, so this we are going to make in different parts. Okay, if we will take, this is an object of different shape. Okay, so from this also we can find the center of mass for these particles also. How can we find the center of mass of for these particles? We are going to make into pieces. For example, let's consider a symbol of F. This is F. So can I make it as one part? I will make it change of color. So this is one part, this is another part, and this is another part. Three parts can I make? If not, you can make in another way also. That is, you can make this as one part, this as one part, this as one part, and this as one part, right? Different parts. But if you add all together, then also we can find the method of decomposition. How it's gonna be find it out? Let's see now. So same, let's take that F itself. Okay, this is the one. Now let's consider this distance is 10. This distance is let's 6. This will be the 4. This is 2. This side and this side, let's take it's also 2. This side is 2, and from here to here it is so here to here it will be 2 only. Okay, right. So now I'm going to break this into multiple pieces. How can I break it? Let me break this as one piece, this as one piece, this is one piece, this is one piece. If not, sir, I can't break that many pieces, is any simple way? Yes, we can break this total as single piece, and this one is this is another piece, and this is another piece, three pieces. Okay, so let's break into as your wish three pieces. This is one, this is one, and this is the one. Okay, what is this total length? 10. What is this? 2. And from here to here this total is, from here to here is 6. Then we consider this is only, no, this is the one and this is the one, that is 4, and it is 2. And for this is 2, this is 2, so this is 2, this is also 2. Now let's consider this is m1, this is m2, this is m3. All the masses are not equal, no, different masses, right? So now all are linear. So linear, this have one rod, so let it can, it is have area. So density equal to mass by area. Okay, it's a surface density. So mass equal to m1 equal to density into area. Area is 10 into 2, 20. For m2, m2 is 4 2 is 8, 8d. For m3, 2 2 is 4, it's a 40. So it is 20. So m1 we have, m2 we have, m3 we have. Okay, now let me find, consider this is an our origin particle point or a. Okay, that point will be taken as 0 comma 0 origin point. Okay, got the point? Next, so from the origin, for this where the center of mass, it lies center with the horizontal distance, so total distance 2, here it is 1, here it is 1, so it is in between. So x axis, that means x1 is 1. Okay, now for this particle, what about for x2? X2 is, here will be, for this, here it will be, how much it is? 2. Here it is 2, so 2 plus 2, that means from this point, from this point it is at a distance of here, right? So what is the distance from here to here? This is 2 and this is 2. Okay, it is 4. X2 is 4. Then what about x3? X3, that means here, this is 1, this is 2, then it is 3. Okay, then similarly for y1, y1 is how much from here, for this, at this point means from here to here how much, totally 10, then it is 5. Y1 is 5. Then what about y2? Y2 for this particle, it is 1. And for y3, from there to here, no, here means this is 1, 2 plus 2 plus 1, so it is 5. So x1 y1 we have, x2 y2 we have, x3 y3 we have. So x center of mass, what is the formula? m1 x1 plus m2 x2 plus m3 x3, as I have considered three different masses, by total mass m1 plus m2 plus m3. Okay, so from this, x center of mass equal to m1. M1 is 20d into x1 1 plus m2. M2 is 8d into x2 4 plus m3 4d into x3. x3 is 3 by 20d plus 8d plus 4d. Okay, so it is 20d plus 8 4s are 32d plus 12d by 20 28 plus 4, it is 32d, and from this 30 40 50 60 64d by 32d, dd gets cancelled, 32 ones are 32 twos, so it is at 2 centimeters. Okay, all considered in 10 centimeter, 4 centimeter, 2 centimeters. Okay, similarly we have to find YCM. So y1 is 5 1 5. Okay, yes, y1 is 5 1 5. That means YCM equal to m1. M1 is 20d into y1. Y1 is 5 plus m2 8d into 1 plus 4d into 5 by this total. What is the total? 32d. Then that will be equal to, so it is 100d plus 8d plus 20d by 32d. So it is 128d by d. I mean 32d. d gets cancelled. Okay. So 32 ones are 32 fours. So it is 4 centimeter. So what is that? It is coordinates is 2 comma 4. 2 comma 4 is the center of mass coordinates. What is the distance? Distance will be these two only. It's root over 2 square plus 4 square. It's root over 4 plus 16. It's root over 20. Okay, that at that distance center of mass is exists. Okay, so this is about method of decomposition. Okay, from which point you are going to take, that is the matter. You are going to take from here or from here or from here or from this point, depends on the point where we are considered. Okay, clear? Right, next will be method of decomposition completed. Then next will be method of integration. Method of integration. So for discrete particles, method of integration can be done for mass distribution. Okay, continuous mass distribution. Let's take one rod or different particles. Now what is the formula for center of mass? Summation I equal to 1 to n mi xi by summation I equal to 1 to n mi, right? So this is the total formula for discrete particles to find the center of mass. When comes to integration, continuous distribution, mass continuous distribution, this formula simply will be written as integral x dm by integral dm. This is for x center of mass. For y center of mass, this will be written as integral y dm by integral dm. Similarly, for z center of mass, integral z dm by integral dm. This also be simply written as integral x dm by total mass. Integral dx is nothing but x. So integral dm is nothing but mass, that is the total mass. So integral y dm by total mass. Integral z dm by total mass. Okay, got it. So this is for integration when it is continuous distribution xcm, ycm, zcm. Instead of taking this, you can take this integral xdm, integral ydm by m, integral zdm by m, where capital M is the total mass, where dm is a small element. So let's take this rod. Here I consider small element of mass dm. From here to here, it's a distance of x, that is this x. Okay, clear, right? So this is the simple method of integration. Okay, now so rod of uniform mass distribution has taken of length L and mass total M, and generally where the center of mass will be exist, it will be lies at the center, but I don't know, I am about to find the center of mass by using the integration method. Let's consider this point is 0, origin point. So from the origin point, let's consider some element at this point. So at this point the mass element is dx dm, and at a distance of x. Okay, it is at a distance of dx x, and the mass element is dm. So what is the total mass per total length? That small mass per distance, dm by dx. So from this, dm equal to total mass per length into dx. Okay, d dm equal to m by l into dx. Now what is the formula for center of mass? Integral x dm by integral dm. Integral dm means I told it will be written as capital M, total M, right? Total mass. So x center of mass equal to integral x dm is nothing but m by l dx by m. M by l taken common. So m by l equal to, from where to where limits, from 0 to length L, total length, from 0 to length L. So m by l by m integral 0 to L x dx. M gets cancelled. Then x center of mass equal to 1 by L integral x dx. It's nothing but x square by 2 from the integration. Limits from 0 to length L. So x center of mass equal to 1 by L into upper limit minus lower limit, that is L square by 2. L gets cancelled. X center of mass is L by 2. So where the center of mass is lies, it's exactly half of the length. That means here only, no. So by using integration also we can find the center of mass.